Today's lesson are the last two lessons of Chapter 7. We're going to start with the inverse of a function. And an inverse is a very simple process where you switch the x and y terms around and then simplify for y again. So, if you see this notation with this -1, that means they want the inverse. Now, we've used our calculator before with the inverse because, like, when we use trig stuff and you want to go back and find an angle, you use, like, the sine -1 that's right above the sine key. Those are inverses. So if I gave you a table and the equation was y equals 2x minus 3, here is a table of the x and y values. If I wanted to find the inverse, all I'd have to do is just switch the x and y around. Now, for us, we're going to take the equation, and now I would like the inverse. So when I deal with the inverse, I'm going to change this to the x, this to the y. So if you notice, I just interchanged them. That's basically all I did. The only thing left to do is to get it in the form that we could put it in the graphic calculator. And so we're going to solve for y. So I'm going to add a positive 3, and then I'm going to divide by 2. And here is my table.
Wouldn't it be 3 over 2?
It would be. Thank you. Mm-hmm. So if I would put a -3 in here, if I put a -3 times a half, I get a -3/2 plus a +3/2, and I get 0, just to show you that it checks. All right, so let's take our equation. So our original equation was y equals 2x, was it +3 or minus? Minus 3. And then we have our inverse. All right, so those are two graphs. So what we want to do is we want to look at what their graphs look like and how they're related. So I would go to a -3, then I go up to over 1. Then I would go to the second equation, and I would start at 1.5, and I basically go up 1 over a half, up a half over 1. And here is its line. Now, to make it more logical so you can actually see how they're related, I need one more equation. And that equation is this guy right here. This is the line y equals x. So if you look right here, I would flip straight across. They reflect. Here they reflect. Here they reflect. They're reflected across this black line, y equals x. Okay? They reflect straight across. So when we have an inverse function, here's our original, here's our inverse, they always reflect over the line y equals x. Okay? So let's go back to this function. Now, in this particular guy, just a little bit more complicated because of the squared. So if I'm going to find the inverse, what would I write down?
X equals y squared plus 3. So
the squared stays where it is. So you just physically move the x and y around. So here I'm going to add my -3. And then I'm going to take the square root of both sides, knowing that I have plus or minus anything, I have to take the square root, and I have x minus 3. Now, if I graph this, I would get something that would look like this, and you can obviously see it's not a function. Okay? So what I would like you to write down right now is write down the inverse, switch the x and y, and then this thing means inverse. And you don't, the rest of these are just examples. So write those down quick. I have one more thing on inverses to do before we get to the second half of the homework. you may be asked to graph both the original and its inverse. You probably want two different colors. Use a pen and a pencil so that you can kind of see it.
So wherever it says graph, use graphing paper.
Please. All right. Any questions about how to deal with an inverse?
So anytime you have like a y squared,
Mhm.
that it's gonna be a non-function?
With y squared. But again, if I would have graphed this original one, it would have been up here. And again, the line y equals x is what they reflect across. Now, the only thing left we need to do with the inverse function is they're going to give you a function, and then I went ahead and I found the inverse. They want to do a composite function with the function and its inverse. And you remember what fog means, except this doesn't look like fog, right? A composite function. So I'm going to take this piece right here, and I'm going to put it into the f. And I'm going to put this piece into this variable. Well, if I do that, I have 2/3 times this 3/2 x minus 3. Now I need to simplify this down. Well, 2/3 times 3/2 makes 1. 2/3 times a minus 3 would be a negative 2. What happens if you do a composite function of a function and its inverse? You will always get y equals x. Because that's the relationship. And that's what a composite function does. All right, questions about the first half? And again, you don't need to write this down. The second half, we're going to talk about graphing radical equations. We have done this before, except we use a little bit different notation. Now, remember the vertex form?
Yeah.
This was a vertex form that we did, yes you do remember, when we were dealing with quadratics. We could take this same knowledge and change it to this. All of the rules that we had for what the A did, what the H and the K do, are the same. So, if I gave you the equation y equals the square root of x, that's the parent. Alright? So, if I gave you this one, left or right? Right.
Right.
Because the negative is part of the formula. So this one would go right 3. And if I gave you this one, you would tell me it goes
Left 8.
no, up 8, because that's why you almost got to keep track of where your radical piece is. Here we go left or right, nothing. This one is up 8. So what I'm going to ask you to do, and you just have 4 problems, and I'm not even sure it's on the test. I don't think so. Is that I want you to graph the 4 radical equations, use graph paper, make sure you understand if they talk about a parent, and then how the equations move left, right, up, and down. Now the coefficient out in front will either shrink or stretch them just like they did for the quadratic. So do you have any questions?
Realize super duper fast. What is a K and H and A stand for?
Basically, in the quadratic, they stood for the vertex. Here, they just stand for a place that we moved.
Oh.
Okay? That's all they do.
Do we need to write that down?
I want you to write all of this down. And then, we're done for today. So you can turn that off if you want to, Dylan.